In this video, we will see how Rafay streamlines the EKS-A bare-metal cluster provisioning. Now, there are a couple of provisioning steps. First step is installation of Rafay Gateway agent on a machine which is in the private data center. Once this agent is installed, it will create an outgoing connection to the Rafay controller. Now, second step is basically preparing the target cluster configuration. This configuration will be used to create the actual Kubernetes cluster. Now, let's look at the sequence diagram. If you see, the admin or the user will basically submit the required Kubernetes cluster spec, and then if you see the gateway, there's an outgoing connection from the gateway to the controller. Using that connection, the desired spec will be pulled into the private data center, and then we'll create a temporary management cluster. On this temporary management cluster, the provider related services, provider in this case is Tinkerbell as well as EKS-A Bare-Metal provider. All the services related to these two providers will be installed on this management Kubernetes cluster, and using those services, the actual target cluster will be created. And once the actual target cluster is created, all the services, which is provider related services from the management cluster, will be moved from the management cluster to the actual target cluster. Once that pivoting is done, the management cluster will be deleted from the machine, and then the remote management of the target cluster will be done from the Rafay controller. Now let's look at the configuration. First step is to create a gateway. Now here is how you create a gateway. You select a gateway type and hit on create. Now let's look at the view details of the gateway. It will have a setup command that we will be running on a machine which is in the private data center. Now let's SSH to the machine. Now let's copy the setup command of the gateway object and run it here. You go copy and then just paste it here and click on enter, and this is going to run an infra agent, and it runs as a systemd process. Let's look at the status of the infra agent by running this systemctl status infra agent.service. Now it shows active. Now let's look at the health of this gateway from the Rafay controller. Yeah, it is healthy. Now the second step is to create the cluster. Click on new cluster, create a new cluster, continue, click on private cloud, EKS-A bare-metal type, and then just give it a cluster name, demo EKS-A BM cluster. Yeah, click on continue. Now let's just fill in the cluster form. Now select the gateway that we just created, give the Tinkerbell IP. It has to be a available routable IP in the network. Now let's create a template configuration. First template configuration is a control plane template, Tinkerbell template configuration. Give it a name, which is the Tinkerbell IP got auto populated. Let's give a gateway name, and the gateway IP, and the gateway IP can be fetched by just clicking on this gateway IPs button. It's going to give you a list of routable IPs, and you can just select from the available list and then just configure it here. Click on create template, and this is how the Tinkerbell template configuration looks like. Just hit on save. Okay, now we have to create worker node template configuration. Give it a name. Now same Tinkerbell IP and the same gateway. Yeah, let's give the gateway IP. Select the rest of the configuration, platform, OS, whatever you would like to configure, and then just hit on create template. And this is how the worker node template configuration looks like. Click on save. Now let's create a machine configuration of control plane for control plane. Now let's give it a name, machine config, and select the control plane template config, and then just configure the selector. It is a key value pair. Now give a username and the SSH authorized key for the control plane. Now let's create a worker node machine config. Give it a name, select the machine template config of the worker node, give the selector a key value, type DP data plane, and give this SSH key and the username for the worker node machine config. Click on save. Now let's give the endpoint host, which is a control plane endpoint host. It has to be a routable IP and free IP. Select the control plane machine config. Now give the worker node configuration here, name, select the worker node machine config, and then cilium policy mode. Now let's configure the hardware config of the each node. This is the control plane hardware config: IP, MAC, name server, mount, and the selector. Now let's give the worker node hardware configuration. Same details here. Now let's verify everything is fine. Yeah, things are looking okay. Yeah, the provision will take around 30 to 40 minutes. Now this is going to go on a series of steps. It'll install all the tools. Now you can see how hardware config looks like, and this is how the cluster configuration looks like. It'll have template config, machine config, all the cluster related configuration. Now let's see where the workflow status of the worker node. It is showing state success. Yeah, I think things are looking good. Yeah, it provisioned and both the nodes are running now. See, both the nodes are running. Yeah, our cluster provisioning is complete. Now it's waiting for cluster to be healthy, and cluster is provisioned with 1.24 Kubernetes version. Now let's look at the deployment. These are the deployments, two deployments. Now these are the Tinkle build details, data center details, and the template config details, the machine config details, and the hardware config details. Now let's try to do a kubectl and run a bunch of commands. Get node. Now let's click on the kubectl link. Now let's do get nodes, and here are the two nodes. Get pods. Oops. Yeah, this is the pods running on this node. So thank you so much. Bye bye.